let's go ahead and actually get things. Sorry, let's go ahead and get things going, and we'll just have time. Hey everyone. So my name is Alex, and oh, perfect. There he is. My name is Alex. I'm the organizer for Monthly Data Nerds. Thank you everyone for coming out. I'd like to thank Belmont for providing us a location for us to meet, and I'd like to thank Tech Systems for bringing out coffee and food. And this month we have John Berryman, the founder of Data Nerds, in the house, and also he runs Penny University. And I highly suggest hitting him up and asking him about that if you're interested in getting into anything related to data. It's a great group, but I'll let him talk about that more.
I'll do a commercial at the end.
Yeah. So without further ado, I'll let Tech Systems talk for a few minutes and tell them a little bit about themselves, and then we'll get started with John.
Sure. Thanks, Alex. My name is Chris Haig. This is Matt Taylor. We work as part of the Tech Systems Nashville team. My office is down in Franklin. I recruit specifically within the data analytics space, which is why it's me that's here, not some of my colleagues. Matt's an account manager. Recently actually moved through Nashville, similar to myself. We're glad to talk with you about the job market locally.
So you'll be DJing. Little introduction. Hi, I'm John. This was me before, actually. Life is different now. I started out with a degree in aerospace engineering. Found that I had a love of math and computer programming, and I didn't really care about all the specifics about like airplanes and satellites and stuff. So I moved into a field better suited for me, search technology. I was a consultant for quite some time. Ended up writing a book, at least part of one. And that's me on the cover. You can see the similarity with mustache right there. And until recently, I was the discovery engineer at Eventbrite. But as of 6 months ago, I moved to GitHub. So these slides are already just a little bit dated. But the work I'm going to be doing is the work that I did while I was at Eventbrite. Now, one thing of interest to you, probably surprising interest, this is my Twitter account. It's interesting to you because an easy way of getting hold of these slides is that account right there. I'm going to post the slides as soon as we're finished with this, so you can have access to everything, and there's a lot of clickable links and stuff. All right, so before we get started, I always like building context. Tagging. What is search-based? But there's also a lot of products online that they're a glorified search application with a nice front end. So Expedia and Airbnb, these are all just search applications, basically. And then even the products that aren't search applications, search is embedded all over the place. So Facebook is, social networks. But how do you find people? Well, you can look them up, and there's a lot of other different things that you can search on Facebook. Twitter has horrible search, but it is another example. and Instagram. So it's just, you'll see the search box everywhere. Now, when it comes closer to what we do at Eventbrite, we think not just search, but like e-commerce search. We've got an inventory that we're trying to sell. And e-commerce is, again, powered by search. Here's Zappos, who's one of my first clients when I was a search consultant. And here's Amazon. There's a very good book recommendation right there. And whenever you get into these search experiences, they're all very similar. You have typically the search box at the top. Whenever you type in something, you get like the set of results. Every result will have enough feedback so you understand kind of what's in that item. And then if that's not satisfactory, then you have this experience on the left side, the so-called facets. That's what I want to zoom in on. Whenever you use this left side, you engage in kind of a browsing experience. You slice and dice the data set to get down to the information that you want. And how do you slice and dice the data set? I know this is way too small to see, but like when you're looking on Zappos for like different types of clothing, then there's categories: men, women, boys, girls, product type, shoes, accessories, bags, price, expensive like that. These are all ways of just taking the full data set and slicing it by dimensions. And these pieces of information are tags. These are the very tags that I want to draw your attention to. And why are tags so very important? Well, recently, the paradigm is shifting. Everyone interacts with the internet through this as opposed to through this. And when people are using that, you know, how many fingers do you have for typing? You have 10. How many thumbs do you have for typing? You've got 2. So people don't like typing nearly as much. And so mobile users prefer kind of to go through this browse experience so that they can quickly slice and dice and get to what they want to. So it is absolutely important, if you're going to build one of these experiences, to have a good understanding of the space and good tags. So to answer the first questions, what is tagging? Tagging really is the ability to understand and categorize the content that you're giving to your users. And why would you want it? Well, if you're selling something, it's because this is how people are experiencing the inventory right now. This is how they're buying stuff. So it's become super important to have useful tagging. So let's get to some practical issues. How does one often tag their inventory? Several different possibilities. One thing is that you can get the users, you can hire curators to tag the content. Basically, you say, I'm going to hire a whole set of people in my team that are professionals at whatever this domain is. I will train them how to, you know, what this taxonomy of tags are, and we'll get them, you know, an army of very smart people. The benefits is that you have absolute control over the way products are described. You control like the vocabulary, the methodology for determining, you know, inclusion in these different sets. But the drawback is probably pretty obvious. It's expensive. The people that you're hiring are often experts, like maybe even PhD level, depending on what you're looking for. So getting this army of people is going to be challenging. Training them is going to be challenging. So the next thing we can do is look at having our users to tag the content. This is a great example of this. Is when you go to like Home Depot or Lowe's or something like that. They don't have like a big warehouse full of all products that they sell and bring it out. They have different suppliers. So, you know, products come in from all these different companies, and it is the job of their suppliers to help tag their stuff. So the benefit of this is the content creators, the suppliers, they know their product best. So they should be able to tag them as accurately as anyone else you'd think. It also scales very well because you don't have to hire anybody. You just say, you know, the more products I have, the more companies that are supplying them, but they just do it on their own. The drawback, though, is you have to prove to these people that it's in their best interest to do it. With Lowe's or a Home Depot, it's obvious if you want to sell your stuff, you got to start tagging it so we can get it in front of the right eyes. For Eventbrite, for example, it was not super obvious that an organizer tagging their events would be meaningful at all. So that's the challenge with that one. You also lose some control over the taxonomy and stuff as well.
I was just going to ask that. They use different terminology for the same things.
You would have to make this type system work, you have to communicate, here is the categories that you have to tag things with. We're going to do the best we can to get you tagging stuff correctly. It is in your best interest to tag them correctly. But you also have people that can monkey around with the system. It's also in their best interest to sell their stuff. So maybe they just tag it with everything. I mean, so you have to set up systems to figure out, you know, when they're cheating. And the final one, the thing that I think I'm most personally inclined towards, if it works out, is to have the customers themselves tag stuff. Because, and this is the key benefit for this, who knows better how to tag things that are being bought than the people that are buying them? Even a lot of times at Eventbrite, where we were selling events, we found out that the way that the organizers categorized events in their heads was in a very business mindset about how they would be. It was kind of like a back office type tag set that they had in their head, because that's what they deal with every day. But the customers, they want sip and paint. They want you know, jazz live performance. They want piano bar. They want this whole bunch of different tags that are very different from what the organizers have. So the benefit is they know exactly what they want. They have whatever vocabulary you come up with, the user's vocabulary is the right one. The drawback is there is even less chance for them to tag. why would a user actually go to all this extra work, like cataloging, categorizing stuff? And we puzzled over this a lot at Eventbrite. We tried one things that you can use, one things that I think people do use, is kind of the narcissistic, look at all the cool things I've done. So we could build like your own landing page, like look at all these events that I've, here's the party events and the jazz live bar. And so we thought about, would that be enough? And nothing we came up with was really satisfactory. So all these ways of tagging have some benefits, but there are also a lot of problems. So it begs a really important question. What if no one's really willing to tag your content? So about a year and a half ago, it's been a while now, we made an interesting observation at Eventbrite. Let me tell you a little bit about our search experience. Every day, millions of people come to Eventbrite and search for things to do. Of these people, of these interactions across a month of time, there are about 500,000 distinct different queries that people enter in. Now, the interesting aspect of that is there's an incredible long tail dynamic where even though we've got 500,000 different distinct queries, the top 1,000 most common queries account for roughly 41% of our traffic. So, there's actually not that many things that people are looking for when you look at it from that perspective. What's more, the things that people were looking for looked a lot like what we want to tag with. So it's probably a little bit too small, but some of the things that come across pretty often are things like business events. Business, kids, networking, Christian, free, 5K, back to school, job fair, 4th of July, baby, real estate, car show, all these things that people are searching in is exactly like when we were thinking, what is the vocabulary we use to describe our events? We didn't think of this stuff. This is exactly what our users are looking for. This is exactly what we want. So, can we use the log searches as a training set to build automated tagging for Eventbrite? And I hope that's true, because the title of this talk is Search Logs for Equals Automatic Tagging. So, here's the setup, and then we'll dive into how exactly we accomplish this. Assume that we are given 3 tables. You don't have to assume, we are given these 3 tables. One is the search logs themselves, which it's like if a user types in a search, we know what they typed in, when they typed it in, and what basically the ID of the search. But we also are able to connect it to a click log. So whenever a user types a search and then clicks on something, we know that this click was associated with this search. So we can join those 2 together. And then we have, obviously, we're an event website, we have the event table. So whatever events were clicked on, we know all the metadata associated with those events. That's all we need. So here's how we'll build our output. Step 1, we're going to find, I'll make a cutoff, we're going to find the top 500 most common queries. Step 2 is for every query issued associated with one of those really popular words, we're going to find all the events that were clicked on. Step 3 is that for all those events that were clicked on from the popular queries, we're going to find their metadata, their title and description. And effectively, that's our training set. The training set, there's the input training set, and there's the labels you're trying to match on. The input in this case is the titles and descriptions of those events. And the output that you're trying to learn is whatever search led to those events. Does that make sense? Mm-hmm. So effectively, we're making a predictor of what searches will lead here, but that predictor is exactly a tagging model, right? All right, so now let's dive directly into the notebooks. And probably tiny. Is that like even legible at all? It's almost. Let's see what happens when I do this. Perfect. Yeah, and it holds on the screen. Okay, we'll go with that. Thank you for your recommendation. All right. So you guys are all familiar with Python notebooks, I presume. This is. We're not going to get into the grittiest level of details, but I'll go through how we took these data sets, joined them together, and built the tagger that I'm talking about. I'll talk about some issues that we ran into and how we fixed them. And then we'll close it up and have questions and talk about whatever you guys want to talk about. All right, so the first part of this notebook is shows you the data set so that you have an idea of what we're looking into. I've already done, probably I should back up just a little bit. This used to be a really cool live demo, like where I'd actually like muck around with data, and then I quit. So you don't exactly get the live data after that. And it's a little bit unfortunate. There's actually some really cool things that I could show you that involve just me refreshing with like random stuff. And if you look really carefully, I think there's some places where I have embarrassing data come through, just because, but it's frozen there now, so don't tell nobody. Don't look too hard. Here is where I have created effectively the raw training set. I've already joined together the queries to the clicks to the event metadata. And what we have right here is we have, in this column, queries that in real life led to a click on an event with this title in this body. And so you can get an idea that it works. Blockchain, a query for blockchain led to an event called blockchain, smart panels. Makeup, there's two queries here that comma delimited. A query for makeup classes, and separately, a query for beauty led to NAR Summer Mega Event. I don't know what that is, but it has cosmetic and Nordstrom and stuff that we're interested in. And if you're to look through this, it's a good starting training set.
Can I ask you a question?
Yes, please.
Is this events are kind of like shown to user, or user actually went to the web page of these events?
Users, in this case, typed in the word yoga on the
Right.
front page of eventbrite.com and saw a list of events,
Right.
and one of the events that they clicked on
Okay.
was Sunday Yoga.
Gotcha.
Yeah, and I think I've also got some cutoff on this so that if it appears in my data set, then this occurrence happened more than once. Someone typed in yoga and led to this. Someone else typed in yoga and they eventually clicked on it. I think your hand was up first.
Do you have the information of what they actually made an appointment for? Because that's the thing you really want to predict ultimately.
That is an excellent point, and we looked into that, and there was just not enough data to really draw good conclusions from that. It turns out that even though you could easily have a situation where someone clicked on an event, figured out it's not what they wanted, and they went back, but the signal was strong enough, it was still a good enough indicator that this was about yoga, in this case, that it was so useful for tagging. It wasn't, if we went with your data set, presuming if it was big enough, then we would have, not only would it tag events, but it would slightly probably promote the good events as well.
Maybe order them by likelihood.
Yeah. Likely to purchase.
What percentage of customer actually make an appointment? Whoever who success.
Oh, I'm not sure. It wasn't super high. We had a lot more people looking for stuff than actually buying stuff. Okay, so data set makes sense. All right, and as you guys know, computers don't read very well. They like numbers. So we create our training set that's appropriate for the model that we're going to use. In the modeling, a lot of you guys are better data scientists than I am, so forgive me. I'm going to use a deep learning model, which basically means I'm going to give up on actually thinking about it and start just dumping data into the system. But at least I can show you my approach, and we can talk about ideas later for better approaches. Always take your data and split it into a training set and a test set. That's what I do in this cell. We're going to train on one set, and then to make sure we're not lying to ourselves, we'll test it on the test set to make sure that we haven't trained on the same data that we're testing on. So we have basically two inputs in X, two inputs to the model. One is the title, and one is the description. The title is typically 2 to 5 words long. Descriptions like I don't know, 10 to 100 words long, something like that typically. But what we're going to do is turn those into TF-IDF vectors. TF-IDF, Nah. TF IDF. So some people know what it is, but to go quickly, TF IDF stands for term frequency inverse document frequency, and basically it's associating every word from the title. Let's use that field. It's saying, okay, this, there are say 20,000 words that people used in the title vocabulary, and this let's see what's a good one. Rap Rally London had 2 words in it. This word occurred, and they both occurred once. So your initial thing is you have a vector for the title that's now 20,000 long, which is all zeros except for 1 in the place corresponding to Rev Rally, 1 in the place corresponding to London. And now you want to weight things based on how frequent the terms are used. London occurs relatively common in our events. We have a big London office, big London setup, and so you would weight that word more highly, less highly because it's common than Rev Rally. If someone is typing in Rev Rally, then they must really mean this because it's such a rare word. So the end vector for the title is mostly zeros because you only have 2 words in the vocabulary actually used, and then you have some number for London and some really high number for Rev Rally. That's what TF-IDF conversion does. We do TF-IDF conversion for both the title and the description separately. Get the term statistics separately, and then once we have vectors for both of those, we concatenate them. And again, it's fairly naive implementation, but it happens to work pretty well.
So I have a question about the search. When you were doing the TF-IDF on that, did you just tokenize the entire search, or did you do any kind of engram on that?
We tokenize. Are you talking about the user search?
The user search, yeah. So for example,
Well,
if that ultimately becomes a tag, and the tag would be a 2-word tag, how would you keep that together?
Okay, now that's interesting. Good point. Whenever we're going to do kind of TF-IDF to the title and description on the input, and the output label is going to have something like that, and I'll explain a little bit
got
deeper.
it. Cool. Okay.
But to his point, with the text descriptions, we got to chop it up into words. But if you chop up, I don't know, like jazz bar into 2 different words, then jazz is a very different tag from bar. It's a very different tag from jazz bar. So what we did is the title and description got turned into these long TF-IDF vectors. The tags were handled by not chopping them up. We said you've got the 500 most common words. They have a semantic meaning in isolation. I don't want to chop them up. And rather than doing TF-IDF on these words, because you only have, like a search just has one of those tags, it is the tag itself, we just do binary. This event was associated, of 500 possible tags it could have been associated with, was associated with tag 17 and tag 42, something like that.
Was there any value in lemmatization or stemming of the terms, or are they so uniform that that's not necessary?
There's always value in looking at that. I don't think we did any lemmatization or stemming for this.
Stop words?
We did stop words for this, yeah. I did some stop words, cut out the really common things like V and N and stuff like that. So there's a lot of different ways that you can treat this. But that's really not, the crux of this thing is just like how we got this weird data set into a form where it's like our users are telling us information.
I was wondering, like, the data set itself is, the search engine's indexing with probably TF-IDF or something similar, so I was wondering, like, isn't this sort of like, I don't know, just matching what the search engine is doing? Like,
Yes.
could you use TF-IDF as a way, just like an unsupervised way to, like, get your tags?
That's a really good question. I'm trying to figure out if I should address it right now or talk about it later. What's your name? Ben asked a really insightful question. If we're effectively matching the user's typing terms to like where we've already chopped up this into words anyways, it's doing exactly the same thing as doing, right? And the answer, I'll say, and I think I'm right, is not quite. And the not quite part is the important part. Because what happens, and we'll see in a little bit, is because this search term gets associated with this text, it also gets associated, certainly a person, the data set is people typing in this search, and it matches an event that literally has that word in it. But that event also has a lot of other words that are highly associated with that tag. And so by doing this, even though it is biased, and we do suffer from the bias that you're pointing out, we are building up statistics about how often jazz bar would be associated with other words that are commonly in jazz bar events besides jazz bar. Jazz bar is going to be the most important word, but other words, piano and stuff like that, also kind of help push it up to the top. Feel free to ask that question again in a little bit if it becomes clear how we can talk about it. It's an insightful question. All right. Okay, so in dealing with the input, the title and description end up getting concatenated into a bunch of training examples, 14,000 training examples, and the feature space is 13,000 wide, which is not as many training examples as I like, but again, with my same answer, it seemed to work pretty well. The end result is something that a computer likes. It's big sparse vector, and the elements that are non-zero are all just kind of like around 0.5, something like that. Very similar thing with the search tags themselves, but the end result is just a 0 or 1 vector, binary vector. We have 500 possible tags, because that's what we narrow down our training set to, and most events will have 1 or 2 or 3 of those go into it. Okay, so now since we have the X and the Y, then we have the magic training desk we need to dump it into the model and see if stuff works out. Because I was enamored with deep learning and all the buzz of the past couple years, I took a stab at learning Keras neural networks with this, and I tried to be really clever, but every time I tried to be really clever, the model worked more poorly. So then I just did more and more dumb stuff until basically I wasn't using Keras for what it's meant for at all, hardly, but it worked pretty well by the endpoint. So it's a neural network. We have an input and an output, and we have basic matrix multiplications with ReLU, just a non-linearity between every layer. The matrix, the model itself, the input plane for the model is the same dimensions as the input, 13,000 or so. Then we narrow it down to 500, because that's the size of the output, and then we just do another 500 by 500 matrix transition. At the end of that, I was going to do something. This is where I was like, I know math. I can do something a little bit cool here, and I tried doing. Oh crap! I'm gonna forget the name of it now. Rather than just having raw outputs, I wanted to have outputs constrained to 0 and 1. I wanted basically a statistical distribution over the tags, and so I was using softmax, and it did. So we can talk about why, but it did horribly. It did very bad, possibly because what I don't want necessarily is a distribution over these terms, but I just want something a little bit more generic. Just how you could have more than one term. It doesn't have to be A or B. But it didn't work. And what I did find out is that I could just chop off the end of the thing and let it just be raw outputs and then threshold outputs. And for whatever reason, which I still don't know, it worked pretty well. So this is definitely not the part that you should learn from me. This is the part where you should teach me.
Did you try any kind of other classical algorithm other than deep learning models, like Naive Bayes or multiplication, just to see any Bayesian performance?
No. Would it have been good? Yes, it would have been good. I was using this. So at Eventbrite in my career, I've been like a search guy. So I'm like just a little bit over from like cool data science stuff like this. So a lot of this was my spare time project until it became successful enough. They're like, hey, let's incorporate it into the production website. As such, it's whatever I was interested in learning at the time, which is scarce. I would have liked to compare it to the other ones because I think there's some.
I asked this question because I see that your data set has almost the same number of features with the number of examples, right?
Yeah.
13,000 versus 14,000 examples. So 13,000 is pretty high. So I wonder, for the deep neural network, you may need tons of data
Yes.
in this space because you have 13,000 space. So yeah, I
This is-
wonder.
This is, in retrospect, it's obviously the case, but some of my earlier iterations with the neural network was to add like more layers and see what we could do, like as if it's just like Lego blocks. But obviously that made the system under constrained, and then you just have the garbage. I am, to your point, now I am actually a little bit surprised that it performed pretty well despite that. So lots of things that I would like to learn from this. But let's see, proof is in the pudding. Let's see what it looks like in the output. Here is the terms, the tags that were predicted by the algorithm. Here is the truth, someone actually doing the search for it. And here is just a little snippet of text. So beauty, so got that exactly. The world beauty trail media, that looks like it works. Art, business, meditation, mindfulness. That's a lot of tags that don't sound like the truth of leadership seminars until you start reading the text. Art of mindful leadership, mindfulness is a buzz, blah, blah, blah. And so it looks like it is actually connecting this stuff pretty well. This is a little bit of a surprise, but it has an interesting explanation too. I have a prediction for vendor and vendors needed that was truthfully searched as bridal show, and it is indeed a bridal show. Why would that be? The use case is a lot of people searching for events is not like, I want something fun to do this weekend, but there's actually a subgroup of our users like, I want a job. And so I'm going to look up vendors needed because I want to find all the bridal shows that mention that they're actually going to have, like, they need help, and they're advertising that requirement too. So it's interesting in that we don't necessarily want to surface that tag. We probably need to do some like curation on top of whatever we're gaining here, but it is actually a fairly accurate tag. 5-K run, Memorial Day events, anime, Comic-Con. So that's kind of cool that we got two separate things that mean probably what we want it to be. So, not bad. Hey, there's Glenn's emails. And eventually, oh no. No. Yes. Okay, I'll do that at least one more time. Okay, so how much time do we have left? When do we usually go to? I can probably ought to go.
We can go. I mean, we started a little late, so we
Yeah.
can keep going. If people need to leave, they can leave.
You guys probably don't have jobs, right? Talk to those guys in the back. I'll go a little bit faster because I'd like to get it mostly cleared up. So there's problems with the approach. There's obvious problems with like some of the data science, but there's also problems with beyond that. One of the things that we run into is when we choose the top 500 most common words, most common searches, depending on what time of year it is, there's a lot of synonyms mixed into that. At this time, it was near Memorial Day, and so among the top 500 searches were Memorial Day weekend events, Memorial Day weekend, and a few other variants of Memorial Day as well. And so when you have a vocabulary that's already constrained as 500, and you've further constrained it by having all these synonyms and stuff in it, then it's not as descriptive as you want. It implies that we have actually a smaller real vocabulary than even what we set out to have. And finally, a lot of the tags that we have, a lot of the events that we have are tagged with like 1 or 2 tags. So this becomes like a future work type thing, but we need an algorithm that says, okay, here's all the text, here's all the possible tags it can have, and maybe even here's kind of like, you know, a distribution of like how likely this tag is to be, rather than just a tag or 2 tags. So I'll go a little bit faster through this bit, but an improved approach is to take notice of an extra piece of information that our users are giving us. User searches don't occur in isolation. Users are interacting. It's a conversation between our users. And so what we'll often see is a user will type in something and look at the results, and they'll realize that what they searched for is wrong. They misspelled it, so they'll correct the spelling. They typed in a keyword that they think, that's probably not as commonly used. I'll modify my search and, you know, have this conversation with the search engine, and we'll try to get to the information we want. So if we look at not just the search, but the sessions for the search, we can say, okay, well, these users, all these words are often have stuff in common, and we can start to learn this correlation and build a better vocabulary. So the idea is this. Let's have 2 layers of training. The first layer is to look at these sessions, and rather than say, give me the most 500 common queries, I want to say, give us the most, I don't know, 3,000 or so common queries, but figure out the families of queries within there and chop that off at the top most 500 or so common families of queries. It's a vocabulary that much better describes the space. It describes a broader space. Remember, top 1,000 queries was 41% of our traffic. Top 2,000 queries is about 50% of our traffic. So we're actually covering a lot more of the domain. So let's take a look at how I did this.
So is that saying like during a session you search like bridal, they keep on searching different bridal terms, but what happens if they search like, well, I need to take my dog somewhere because I've been searching bridal stuff the whole time?
It happens.
Okay.
And let's see, let me see if I make this full screen, and then I'll view. Oh, there it is. It happens, and statistically it gets washed out.
Yeah, figured out liars on that.
People do search for other things, and so there is a small correlation associated between bridal shows and dog walking, but it's so small that whenever we start like cutting off which certain terms you use,
Yeah.
it's just noise. All right, so implicitly in the sessions we have this other data set. We have all the terms that co-occurred, all these search terms that co-occurred with other search terms. And it's things like you kind of see here. People are clarifying their search. Memorial Day weekend occurred in the same session as Memorial Day weekend events 4,976 times for this data set. And there's all sorts of variants of that. Job fair, and job fairs, car shows, stuff like that. None of these are terribly interesting. I guess this is probably an interesting. Someone searched for job fair, and let's see, 1,171 people searched for job fair, and then later searched for career fair. That's a clarification. And I thought there was some spelling corrections in here too, but you get the idea, all right? So what we're going to do is we're going to take that data set and we're going to normalize it. You get kind of the. Can I explain this really quickly? You get kind of the Beatles effect. What is your favorite songs? Or what song is closely related to Jimi Hendrix' Purple Haze? Well, it's the Beatles. What's a good Beatles song? I Want to Hold Your Hand. There's a lot of algorithms when you're trying to make recommendations that if you do it naively, it'll say, well, everyone who's listened to Purple Haze by Jimi Hendrix has also listened to I Want to Hold Your Hand, because everyone has listened to Beatles. It's not that those two songs are really closely related. So we need to do something to take into account the overwhelming popularity of some of the searches here. In this data set, Memorial Day was just overwhelmingly popular. So, you know, Jazz Bar is not really the same thing as Memorial Day. So we normalize the data set by saying, okay, we're going to create a graph. Here's all the searches that ever happened in this data set. And the correlation, rather being the count of the core occurrence, is the count of the core occurrence divided by how many times this thing co-occurred with. There's a lot of different ways that you could normalize it, and we tried a few different ones, but that one appeared to be the one that worked the best. And so Memorial Day gets kind of knocked down a lot. Other things do as well. Okay, so at this point, we can create a co-occurrence matrix where on the rows we have every search that is in our vocabulary. On the columns, every search is in our vocabulary, and the values is how commonly they co-occur, the normalized co-occurrence effectively with one another. And it looks something like that. That's a subset. Memorial Day weekend events occur with these synonyms quite a bit, but don't occur with Mother's Day very often. They do some. So imagine all the different spaces that you have. So based on that, we're into a domain that I'm really interested in now is like graph algorithm type stuff. The graphs are naturally like clumpy. Stuff should belong together, but there's no exact cutoff. These are Mother Day and these are Memorial Day because there's a few events that are both. So we use this algorithm called affinity propagation to take this matrix of co-occurrences and say, it's effectively when you run the algorithm, every word is effectively looking at all the other tags that they're associated with and says, I think I might be your boss. I might be the center of our local network. And then it creates its own understanding of the probability that it is the chief of its domain. But it says, what do you think? And it says, what do you think? And it incorporates that in. And a few rounds of us basically slowly bleeding information by asking the neighbors, do you think I'm your boss? Do you think you're my boss? You start to see it clump together, and you get families that kind of merge, and implicitly you get kind of like boundaries in the graph of where these domains occur. And the boundaries start to look pretty reasonable. Let's see. There's some stuff that makes sense out of the context of it, right? Couples, okay. So let's see. The important columns to look at here is this column and the last column. And a group that has the terms couples, date night, and marriage is assumed to be led by the couples. So we call this group couples. And vendors needed, that's kind of the annoying one, right? But it's free vending, events for vendors, that's long-winded. Vendors needed and vendors wanted, all get lumped into that. Hotel and hospitality, let's see. Islamic event, Quran, blockchain, that's probably the most verbose, including some issues, but blockchain is associated with Bitcoin, block space chain, clarification, blockchain, like common misspelling, blockchain week, consensus, but it also has some somewhat noisy stuff in there, and that's associated with AI, because it's like the buzzword events, I guess. But it's interesting. It was a found association. So given that we have this matrix, we used to have this co-occurrence matrix of all tags and all tags. We can start striking rows out of this. We can say, if you were one of the tags and you found out that you weren't the boss of your group, we're going to put your weight onto the boss's row and just kind of strike all the words here. And so what we end up with, without going into the screenshot, is we end up with a much smaller matrix where on the rows it's still all the words that could occur, but the columns we've now erased everything except for the leaders. And basically you have a transition from this big space of 3,000 words to a much more confined, much tighter space, much more descriptive space of about 500 or so words. And if I'm smart, I can go, I did the good thing this time. Okay. Thank God I loaded. So, given that, now we repeat the steps that I showed you the first time. So, super fast version of this. We have, just like the first data set I showed you, we have the queries, we have the name and description of the events. The only thing I've done interesting and different with this particular C data set is I've also included the counts associated with it. So, like, lunch was the originating term leading to this event 4 times. There's one of those embarrassing ones. Don't look. Cinco de Mayo and party and Cinco de Mayo occurred 6 and 14 times correspondingly to the holiday, embarrassingly. Okay, so given this training set, effectively, we're going to do the same processing we did earlier to take the titles and descriptions, turn them into this big long TF-IDF vector, take the tags associated with them, we'll do a little bit smarter and incorporate the weighting, so it's not 0, 1, 0, 1. It actually has the count, how many times it occurred, so stronger weighting towards that. And what we do with it is we take this really long set of tags, the top 3,000 words, and we use that matrix I just described to squish it down into the 500 or so group leaders, the central words in the graph, the locally central words. This is me checking if it works. Building the training set, effectively this is copy and paste of what I showed you in the previous notebook. There's your Keras model, same type input output. And the results look pretty good. So I had different organizations, title, the true queries that were associated with it, and predicted tags. So 5K, that doesn't exactly say 5K run, was tagged and queried appropriately. I find this one really interesting. This poses a really interesting problem for us. This event titled Afro-Caribbean Wine Fest Atlanta was tagged as Afro-Caribbean Day Party, Memorial Day Weekend events, reggae fest, wine tasting events. So Yahoo! I got all the tags I wanted. That's very helpful. But the true signal here was one person searched on it and it was wine, and that's it. So you have a really interesting situation here where your training set, if you're trying to figure out how well this is training, and you compare it with a very sparse training set, you might have something more truthful in a weird way than the actual original training set. So like, how do you compare these two things together? We can talk about some interesting solutions for that that I would have liked to try, but we didn't get into it. But foam, everything looks pretty good. If you look in here, there's some things that are probably spurious. I doubt this was really Memorial Weekend events. This is where the normalization didn't quite work. But all in all, not bad. And I just did the thing again. You go down. Somewhere on this computer. No. Oh. Do I?
There's a tab.
Yeah. There it is.
It
A
says
tab.
4 down.
To the left.
4 down brings up the.
Well, let's see. Here we go. I'll just like represent some other tab I had open. All right. All right. So the end result of that, much fewer synonyms. Blockchain, blockchain, different spellings all get compressed into one thing. Much more ideal. So we have a much richer vocabulary without all this redundancy wasting the space of the vocabulary. There's a lot more sample data. We had to constrain ourselves to a fairly small set. So earlier it was 500. This end result ended up being 2,700 that we squished down to 500-ish again. Not bad. Covers a lot more of our search behavior, about 50%, in broader tags. There are some interesting new things introduced by this that are drawbacks. You have spurious relationships. AI isn't blockchain. And so as the vocabulary shifts and stuff, you don't want to, these are like buzzword events. You don't want that to be the thing that attracts you to the event. You also have, no one knows what Ozio and Rosebar are, I don't suspect. Anyone from DC? And this is interesting. I don't know how to deal with this, besides like this curation. Ozio and Rosebar are two different competing bars. And what happened is someone searched for Ozio to see if they got any events this weekend. If they didn't like them, they'd search for Rosebar. Creates a strong relationship between these two competing bars that my system thinks is a synonym. So that's going to make one of them really ticked off, and effectively our tag is going to be Ozio or Rosebar. We're going to draw them away from their competitors. Let's see. Oh, no reason to use that. So that was interesting. So kind of wrapping up, there's a lot of things that we can do with tags. Once we have these tags, it goes into the user experience. They can slice and dice the data sets. And if it's, this is a screenshot we did for a while, roll this out and let users play with it. There's a lot of behind the scenes type stuff that you can do with the tag set. You can say, you know, if users are looking at these type tags, what other tags are related to them? You can make recommendations about how organizers can tag their own events, because we were still trying to do that as well. You can start to get an idea of supply and demand. The demand is what people are searching for, and now the supply, instead of being tagged with whatever our marketing team would tag it with, the supply is tagged in the same vocabulary, so you've got closer to apples and apples comparison. And so there's a lot of neat things that can come out of a training of a data set like this. Plenty of things to do in the future, not that I'll be doing them, but the long tail is really long. So how do you actually handle greater than 50% of the experiences without going 40,000 terms in? I don't know. That will continue to be a hard problem. How do you judge the quality of the algorithm when the truth set might not be as good as the predictions you're actually making? That was an interesting question, and I don't know how many people know Cheng Li, but he works for Lowe's. And basically, he said that they would ask their suppliers, they would autocomplete for their suppliers with this training set. And if they accepted the autocomplete, it was a point for this. That's kind of a way of getting that justification in. And then there's a lot of other cool things that you could do with it. Tagging is important. Accurate tagging, it allows your customers to interface with your products. It allows you to understand your products better. Tagging is hard to come by. I've gone over the different methodologies you can get it. Most of those are not accessible. But it is neat that, at least as a proof of concept, there is a way of having your users directly tell you what they're looking for. And that, if these methods can be improved, that might be a better tagging set anyways, because it is literally your users saying, this A is B. That's exactly what you want. So that's a lie. I haven't shared it yet, but I'll share it with you, and I'll share it on Twitter. That is my name, JNBRYman, just with all the silly letters removed. Everything here is a link, so if you get this, you can start clicking on stuff and play with the data. Oh yeah, here's my commercial part. I run a group in town called Penny University, which is basically for people that love learning together. If you have a question that you need a quick answer for, you go to Stack Overflow and look up the answer to your question. But if you're learning something, and a lot of the group right now is data scientists because of how we were founded, if you're interested in sitting with someone and learning about how data analyst, data engineering type stuff works, and I've had so many good conversations where I'll meet somebody, have a coffee with them, or meet on a Google Hangout, and unlike Stack Overflow, I get to ask questions back, and we get to narrow down to exactly the thing that helps me, the other person, us both learn together the best. So if you're interested in that, pennyuniversity.org is the name of that, and that's kind of my big side project right now. And that is exactly it.
Yeah, I have a question about the events that were tagged, they were curated, tagged or curated. How did those tags compare to search terms and the tags that were output by your model?
So we don't.
Oh, that didn't happen.
It didn't happen. We were trying to figure out a way of injecting something in the creation flow of events to say, organizers, you tag your events. But the product team was always very concerned about if we put any new thing, that people just won't have events anymore. Like Sally's not going to have a birthday party anymore. So it took forever to get that into the product. We did towards the end of my time there, but I didn't look at any comparisons.
When you use the affinity propagation to find synonymy among terms, what did you then use as the terms that the user saw? Did you have a way of saying, like, the shortest version of these synonyms, or the most orthogonal to other things, or what was the
With the affinity propagation, not only did it group the terms into groups, but within each group, you could see that the probability that it was the leader of the group. So we chose that as the term. And often, that was the best term, because from theory, people type the minimal amount to get the point across.
Was it typically the shortest version of those terms? Like, I would think if I have Memorial Day picnic at Fred's, Memorial Day would be the most frequent.
It's the lowest common denominator for that group typically survived as the leader. So I didn't do the analysis, but just like spot checking with my eyeballs, typically use the shorter version and the more general version of the concept.
All right. We have
Yeah, I
One
have
more
a
question.
very quick question. Probably I should take it offline. But the problem is like I saw that like when you predicted tag, so you could have predicted like multiple tags, right?
Mhm.
So still I got kind of confused, like what is your Y target variable when you were trading? This is what I got a little confused.
The target variable from a human perspective is which searches led to that event. At a level deeper, right next to the neural network, we turned that into a vector, 500 length vector that was sparse and had like the count for every time that word occurred. So you're predicting that effectively.
Okay, lovely. Thank you.
Oh, you're smirking, so I'm in trouble.
No, this is my own embarrassment, kind of smarty, partially because I came in late, so apologize if this is too rudimentary. So basically what you've got here is a supervised learning model where your predicted tags are already tagged with events and provided somehow those tags are already in the database, and then you're mapping from search queries to those tags.
Yes.
Okay.
So you're effectively, I'm calling it a tagger, but you are predicting which search terms will lead to this event eventually.
All right. Well, thank you everyone for coming out. This has been actually our largest turnout ever.
Oh, right.
Yeah, so this is awesome. I'd like to thank John for coming out. He did do this kind of last minute, so I really appreciated him helping out in that way. I'd like to thank Tech Systems for providing coffee and food. Chick-fil-A is always a big hit. Belmont, of course, for providing us the space. And to everyone, y'all make the community. Super happy to see everyone come out. Please check out Penny University. Join our Slack. Engage with us. We are a group of people. We love talking about data, and we love helping people get into data. If anyone has any talks or interested in giving, please reach out to me. We still have quite a few months open in 2020. So this is always, I consider this like a great safe place to kind of work out talks. It can be more of a conversation if you have like ideas. So just reach out to me and I'd be happy to work with you on that. That's all I have. Thank you, everyone.
Thank you.
Oh, one last thing. I will be posting